Hello everyone. So today I'm going to explain a few concepts in database management system and using the Postgresql documentation. Um, Before that, I would like to mention that some of my friends had mentioned that I must increase my the video that is shown below, the size of it. Well, currently that is not possible. Hope it's fine. Okay, so let's start with the first concept, that is load balancing. So what do we mean by load balancing? First and foremost, the basic notion of load balancing is that when the uh, sorry yeah when different computers or servers, you might say, different computers or servers are able to serve serve the same data. This is the basic idea. So if we can allow something like this to occur in our servers, then that is called a load balanced network. Then another important and a very desirable attribute is high availability. So what is it? By high availability, we mean to say that if the primary server, due to some circumstances, were to fail, then a secondary server is able to take over this primary server quickly. So when our system is capable of such an action, we call it a highly available system. So these two things are very desirable. But what prevents us from having these two properties? So the fundamental problem here is synchronization. What do I mean by synchronization and why did it actually occur? So the thing is that database servers are basically of two kinds. There is a read-only server, read-only, and there are read-write both type of servers. So the problem of synchronization does not occur actually in the read-only servers. Why? Because what we can do is, let's say there are multiple servers and we have already uh, written data that is to be fetched, the one that will be read, that is already in these servers. So, and there is no kind of modification that is going to happen through these requests. So whichever way or whichever server is basically requested, we don't really need to worry about the synchronization. But what happens in a read-write server? The issue is that, let's say one of these servers were to get a write request, and this will make the data as this will modify the data basically. So now that the data is modified here, it needs to be propagated to each of the servers in the network, and this may even cause delays. And additionally, there is synchronization issues. Let's say that this were not propagated and some read request were to come here and we were to allow such a thing to happen, then that read request might not be consistent. So to maintain this consistency, we need to basically address this synchronization problem. Okay, so one of the ways to solve the synchronization problem is by giving a what I call as a different set of permissions. So what do I mean by that? Basically, we are going to have just one of the servers capable of issuing the modify request, capable of modifying data. So what does this mean? So there are a few terms in these. The one that is the server that is capable of such a permission is known as the primary server or the master server. Additionally, the one that serves that cannot have these permissions or that is just going to be in the standby. So that is called the standby or the secondary server. Now this one can also be of two types. Basically it can be a warm standby or a hot standby server. So what's the difference? The warm one cannot be connected. That is, it cannot accept connections until and unless it is promoted to a primary server. This is the difference. Whereas a hot server can accept connections, but it is going to be only for read-only requests. That is the difference. So that is one of the ways. So there are two other ways to solve this synchronization problem. So that one of them is the synchronous way and the other is called the asynchronous way. So what do I mean by synchronous? That means that a data modifying transaction is not considered committed until all servers have committed the transaction. So this would guarantee that even in a failover, there would be no data loss. Why? Since all the load balanced servers are at the same state of data. But in contrast to this, the asynchronous one, what it does is it has some delay between the commits, that is at some server, and until it is propagated to the other servers. The thing that we have to consider in such scenarios is basically a difference between two things. One is the performance and second is the functionality. So we know that synchronous is a very good is going to have a very consistent state at every server, at every load balance server, and that should be a very kind of desirable, but this is going to impact the performance. Why? Since every commit is going to be much slower. Why? Because that has to be propagated everywhere at every server, and after all of these servers have committed, then this transaction is going to be committed. So these are the trade-offs that we have to manage in such situations. Okay, that's it. Hope you have understood something new and interesting. Thank you.